In my previous video on rationalizing the denominators, we looked at the rules and procedure for rationalizing a denominator, but at the end of that video we touched on the fact of what if you have a denominator that's a slightly more complex expression that involves radicals. So we're going to take a look at the conjugate today. And the definition of a conjugate is if we have something in the form of a plus b the root of d, its conjugate is a minus b root of d. Let's just look at these three expressions below. 5 plus 3 root of 2. So the conjugate would be 5 minus 3 root 2. So notice we just changed the sign in front of this b root d portion. Negative 3 minus root 6. Well, its conjugate would be negative 3 plus root 6. 4 root 11 plus 1. Well, note that this is the same form as the previous ones, just kind of switched around. So this would be negative 4 root 11 plus 1, or if you prefer, 1 minus 4 root 11. Okay. So what's the purpose? How can this help us simplify these more complex denominators? Well, let's take these expressions and multiply them by their conjugates. So we have 5 plus 3 root 2. Its conjugate is 5 minus 3 root 2. How can we simplify this expression? Well, we can use the distributive property. So this is 5 times 5 minus 3 root 2 plus 3 root 2 times 5 minus 3 root 2. Expanding this out now. So let's take a look at this first product. So we have 5 times 5, 25. 5 times negative 3 root 2, negative 15 root 2. And now we'll take a look at the second product. So we have 3 root 2 times 5, that's plus 15 root 2. And 3 root 2 times a negative 3 root 2. So that gives us a minus 3 times 3 gives us 9. Root 2 times root 2 gives us 2. Note that we have the exact same terms with opposite signs. So those two are going to add to 0. So what we're going to end up with is 25 minus 18. So our final answer is 7. Let's take a look at the second expression. Let's multiply it by its conjugate. So this is negative 3 plus root 6. So what does that give us? So we have negative 3 times negative 3 plus root 6. And then we have negative root 6, once again, times negative 3 plus root 6. Let's start simplifying this a little bit. So dealing with the first product again, so negative 3 times negative 3 is 9. And then we're going to subtract 3 root 6. For the second one, so negative 6 times negative 3, this is plus 3 root 6. And then negative root 6 times a positive root 6, this is minus 6. Once again, notice that we have these two terms that are going to add to 0. So our final answer is just 9 minus 6, which is 3. Well, in both of these examples, multiplying the expression by its conjugate managed to remove any rational expressions from it. Will that always be the case? Well, let's take a look at our general example. A plus b root d. Multiply by a minus b root d. What does this give us? All right, so we have a times a minus b root d plus b root d, once again, times a minus b root d. Multiplying this first product, we get a squared minus a b root d. Our second product, this is plus ab root d minus b squared times d. Once again, note that these two components that have a rational expression add to 0. We're left with a squared minus b squared times d. Now, I'm not suggesting that you have to memorize this expression or anything along that lines, but note that if we have one radical in these two expressions, we have shown that it will add together in order to give us an expression without a radical. This will help us to rationalize the denominators, as we're going to see in the next examples. It's going to be the square of the first part subtract the square of the second part. We're going to start by simplifying the expression. 7 root 6 divided by 5 plus 3 root 2. Now simplifying this is going to involve rationalizing our denominator. Looking at this denominator, we note that it's in the form a plus b root d. So multiplying by its conjugate will allow us to rationalize what's in the denominator. What is the conjugate of 5 plus 3 root 2? It is 5 minus 3 root 2. Now, in order to multiply the denominator by the conjugate, we have to multiply the numerator by the conjugate as well. The reason being, we can't just arbitrarily multiply an expression by a number unless that number is 1, which is the identity element which will not change the expression. And we can see that 5 minus 3 root 2 divided 5 minus 3 root 2 is just equal to 1, so we're just multiplying this expression by 1, just 1 in a form that's going to conveniently help us simplify things. Okay, so what are we going to end up with? We will have 7 root 6 times 5 in the numerator. That is 35 root 6. And then the second part of this expression is 7 root 6 times a negative 3 root 2. So that will be a negative 21 root 12 divided by, well, we have our conjugate that is being multiplied together. What is going to happen if we look back at our previous examples? So 5 times 5 will give us 25. And then a 3 root 2 times a negative 3 root 2 will be minus 9 times 2. You don't necessarily have to write the middle portions if you remember this relationship. That being said, it's possible that you might forget, and if that is the case, working this out with these middle portions, we can see that they're just going to add to give us 0. So those two will just sum to give us 0. We'll have 25 minus 9 times 2. All right. So 35 root of 6 minus 21 times the root of 12. Well, 12 can be broken down into 3 times 2 times 2 using prime factorization. In the denominator, we have 25 minus 18. So, to finish this off, we want to simplify root of 12. So we can do that by taking a factor of 2 out. So we have 35 root 6 subtract 42 root 3 divided by 25 minus 18, which is 7. So we're almost done, but in this specific instance, we have a factor of 7 in 35, and we also have a factor of 7 in 42. So those can be divided out. So 35 divided by 7 is going to leave us with 5. So that's 5 root 6 minus 42 divided by 7 leaves us with 6. So this is 6 root 3. If you're having a little trouble conceptualizing that last step, just realize that I can rewrite this expression like so. You can see that if I subtract these two fractions that I have in the bottom, I will end up with the expression that I have above it. And that might make it a little easier for you to see that this 35 and 7 will divide, and so will the 42 and the 7. This line is strictly optional that I have in yellow, but that is the logic behind why we can divide that 7 among both of those terms. So our final answer is 5 root 6 subtract 6 root 5. Let's take a look at one final example. Root 2 plus root 3 divided by negative 3 minus root 6. Note again that we now have this denominator in the form a plus b root d. So we can multiply by its conjugate in order to simplify it. The conjugate of negative 3 minus root 6 would be negative 3 plus root 6. And we're allowed to multiply the denominator by negative 3 plus root 6 as long as we do the same thing to the numerator as well. Okay, so we're going to want to expand this expression. We have a lot of things to expand and simplify. I'm going to put brackets around this numerator just to ensure that we do not make any sort of error as we're multiplying this through. So let's start with the root of 2 times negative 3 plus root 6. And then we have plus the root of 3. So this is plus root 3 times negative 3 plus root 6. And all of that is divided by, and I'm just going to do this entire expression as well in the denominator. I'm not going to take any shortcuts in simplifying it. Let's write the whole thing out. So we have negative 3 times negative 3 plus root 6, and then minus root 6 times negative 3 plus root 6. Okay, so a lot of things to combine, a lot of things to simplify. Let's get to work. In the numerator, negative 3 root 2 plus root 12. Subtract 3 root 3 plus root 18. So I've expanded the expression here and here into those two portions. In the denominator, negative 3 times negative 3 is 9. Negative 3 times root 6 is minus 3 root 6. Negative 6 times negative 3 is plus 3 root 6. And then negative root of 6 times positive root of 6, well, this is negative 6. We can see in our denominator, multiplying by the conjugate gave us these two terms, which are going to add to 0, which gives us that nice simplification. So what do we have in the numerator first? So we have negative 3 root 2 plus the root of 12. If we were to simplify using factor trees, that would be the root of 3 times 2 times 2, which is just going to be equal to 2 times the root of 3, minus 3 root 3, plus the root of 18. Root of 18, if we were to simplify using factor trees, would be 3 times 3 times 2. And we have the pair of 3's, so that will be equal to 3 root of 2. Divided by 7 minus 6. So this is just divided by 3. So, negative 3 root 2 plus 2 root 3 minus 3 root 3 plus 3 root 2, all divided by 3. What can combine? What can simplify? Well, these are all square roots, so we can add anything together that has the same radicand. So negative 3 root 2 plus 3 root 2, that's 0. 2 root 3 minus 3 root 3 would be negative 1 root 3. So our final answer is negative 1 times the root of 3 divided by 3. That is this fully simplified, rationalized expression. So that is how we can use the conjugate in order to rationalize the denominator of an expression, which is in that form of a plus b root d.